All right, so this is the first of 4 recordings for a review on the final. There's going to be 4 sections, roughly 4 sections that are going to be on the final. The first section, the one that we're doing right now, is on slope. And then the other 3 sections are number 2, mx plus b form, how to write an equation. Number 3, how to evaluate, which means that I'm going to be putting some numbers into a function to see what comes out. And then the 4th subject that's going to be on the final is algebra problems. Algebra problems are when I'm solving for an unknown like x. So this first video is here. We're going to be discussing the slope using 4 different methods of calculating the slope. All right. So here is the first method of calculating the slope. This is the graphical method. Now I need to know, there's really only one thing that I need to know to calculate the slope, and that is that the slope, which is represented by the letter m, is the rise over the run. Or it's the distance up and down divided by the distance side to side. All right, so this is the graphical method, and I could imagine somebody looking at this problem and not knowing what to do because there are no coordinates given by the problem. So you just have to choose your own coordinates. For this particular problem, I'm going to choose coordinates that are whole numbers. And the way to do that is by choosing a point that is directly on top of a grid line going this way as well as a grid line going that way. So for example, this would be a good point to choose, whereas this would be a bad point to choose. This is exactly on a cross. It's got a whole number coordinate, whereas this is a fractional. So it's between the whole numbers -1 or +1 and +2. All right, so the first thing that I'm going to do is label my coordinates. This way is the x direction going in the horizontal sense, and this is going 1, 2, 3, 4, 5 in the domain, and -1, -2, -3, -4, -5. So the domain for this particular graph goes between -4 and -5 and +5. The domain of the graph is from -infinity to +infinity because these lines say that these arrows say that the line extends forever. I've been talking about the domain from left to right, the domain being the numbers on the x-axis. And now I'm going to do the range. So let's number off 1, 2, 3, 4, 5 in this sense, and -1, 2, 3, 4, 5 in that sense. All right, and now I'm ready to choose 2 coordinate points. My first coordinate point is going to be here, and I chose that point again because that's a point where the line, the blue line, goes exactly through a grid point. And then let's follow along. This would be a bad spot. Still bad. That's getting a little closer. This is close, but I think this one down here is probably going to be the best one for me to choose. I could have picked any 2 points that I wanted to. This is a constant slope, which means that the slope does not change. So because it's constant, it's going to be the same no matter what I pick. Now I'm drawing here a shape that's connecting the 2 points that I've chosen, and that shape is the shape of a triangle. And I just am drawing this shape called the slope triangle in order to emphasize what the slope is between the 2 coordinate points that I chose. The first coordinate point being here, and let me make that a little bit easier to see. The first coordinate point being here, and the second coordinate point being here. Now, I could write the coordinates of those 2 points in the x sense. The middle here is at 0, comma, in the y sense 1, 2, 3, 4. Okay, and then the coordinates of this one was in the x sense it was -3, and in the y sense it was -1, 2, 3, -4. So this one was -3 for x and -4 for y. Okay, but I really just need to focus on this slope triangle for this particular calculation. I need to know 2 things: the rise, which is the distance up or down, and the run, which is the distance left to right. Now this line goes from this point on the left to this point on the right. You can see that starting on the left, the line is going up. This is an increasing line, and that means that the rise is going to be positive. Let's see exactly how positive it is. So starting counting at the bottom, the rise is 1, 2, 3, 4, 5, 6, 7, 8. The rise is 8. Now let's double check that that makes sense. What is the difference between the number -4 and the number +4? Well, to go from -4 here to +4 here, you would have to go 8 up, because 4 minus -4 is 8. Okay, so the rise, the distance up, was 8. And the run, the distance side to side, starting counting here, is 1, 2, 3. Okay, let's see if that makes sense. What's the difference between 0 and -3? How far do you go to get from -3 to 0? To get from -3 up to 0, you do count 3 sideways, so that does make sense. And then the last thing I need to do is the slope. The slope is the rise divided by the run. So the slope is the rise, 8, divided by the run, 3. Now, that could also be written as 8 divided by 3. 8 divided by 3 cannot be reduced. 3 does not go into 8 at all, and there's no common factor, and so I am done. This was the graphical method of calculating the slope. It was graphical because I used a picture. If you like using pictures, then the way that you want to calculate slope is by drawing a slope triangle like this one and finding how far up one side of the triangle is and how far side to side the other side is. But there are two other methods. Another method of solving for the slope is the formulaic method. The formula for slope, it's still the rise over the run. However, for the formula, I'm going to use the formula for the rise, that is letters for the rise, y2 minus y1. That's the difference between the 2 points. So for this example, y2 minus y1 would have been 4 here minus -4 here, which would have given me 8. So this is still the rise, it's just a different method of finding the rise. And then over x2 minus x1, and that's still the run, it's just a formulaic method of doing that. Now, let's label my two x coordinates. X comes first, and then y comes second. So these are the two x coordinates here, that's the first x, and here, that's the second x. And the two y coordinates are here, that's the first y, and here, that's the second y. So if I wanted to label those, that would be the first x is x1, the second x is x2, the first y is y1, and the second y is y2. So this is the coordinates x comma y and x comma y. This is the first x and y, and this is the second x and y. And now I'm ready to put these into the equation here. So the two y coordinates are y2, so that's y2 minus y1. So I'm going to evaluate for y2. 2 is y2, so I just take y2 here and I put it right there for y2. And then y1, so that's 2 here, minus -6 here. -6 is going to go here, minus -6. And that's a little bit tricky because there's two negatives there. And then I'm going to divide that by x2, which is -1, minus, and then x1 is -4. So that was y2 minus y1 over x2 minus x1. Where, for instance, x1, what was x1? x1 was -4, and that's the reason for x1 I put -4. Okay, and from here on out it's just some calculation. Now, the only thing that's tricky here is that two negatives that touch, not negatives that do not touch. I'm not referring to things like this. I'm referring to these two negatives that are touching. Two negatives that touch turn positive. Okay, and I again have two negatives touching here. Is that here and here? No, the two negatives that touch are here and the very next thing here. Okay, so those are the negatives that we're touching. And now I can do the rest of the calculation. That's 2 plus 6. 2 plus 6 is 8 over Now that's -1 plus +4, so there's 3 more positives than there are negatives here, so that's 3 on the denominator. Okay, so I'm going to put a box around that. That's the slope is 8 divided by 3 because the rise was 8 and the run was 3. So the two methods that we've covered so far, we're covering the slope, the first of our 4 subjects that are going to be on the final. The first method for calculating the slope was the graphical method because I used a graph. The second method was the formula method, y2 minus y1 over x2 minus x1. Here, let me clear that up really quick. So that was the difference. When I say difference, I mean subtract the difference in the y values over the difference in the x values. That's still rise here over run here. And then I have 2 more methods to cover. One is a method where I'm still going to be finding the difference, but I'm going to call it delta for change in y. And then finally, I have a problem that I would like to do in context. So this is going to be minutes and yards. So that's going to be the next video.